You guys can maybe get online and look at the notes if you want to take notes, if you need to take notes. There's one slide that has all the transformations on it in one big fell swoop. So we're going to talk about all of them, and then you can copy them all down from that slide. Okay? So transformations basically just means it's going to change the graph. You're changing the coordinates of the function. All right? So first one is a cubic. All right? Second one, somebody in words, tell me what happened to that graph. So this is what we did with Desmos. When I have x plus 2.
It's down 1 over to the right 2.
Down 1 and over to the left 2. Remember, if it's happening in here with the x, it's opposite of what you think. Okay, that's the big thing. If it's happening outside, up, down, whatever, that's exactly how you see it. So the translations, minus with the x means right, plus with the x means left. Plus outside means up, minus outside means down. So it's only in with the x that it's screwing up. Okay, this is what I'm saying is on one big slide if you just want to hold. Okay, so you can kind of see. Reflections. Again, if it's happening out here, not inside, it's a vertical thing. So if I'm reflecting points vertically, which axis am I reflecting over? The x. If I'm reflecting horizontally, I'm reflecting across the y. Yes? So it's, you've got to think about it. All right, so a negative outside means I'm reflecting vertically across the x-axis. A negative inside, reflecting horizontally across the y-axis. Yes? Okay. Scale changes. So when you see multiplication to the y, which is the outside of the function, exactly as you see it. If you're multiplying by something bigger than 1, it's going to vertically stretch that. If you're multiplying by a number smaller than 1, it's going to vertically compress that. And when I say smaller than, I mean absolute value, right? Don't worry about the negatives. The negatives are flipped. Okay, so we're talking between greater than 0 and less than 1. All right? Vertical things are exactly how they seem. If it's a horizontal scale change, it's happening inside with the x. It's the reverse of what you think. So if it's bigger than 1, instead of pulling it horizontally, it's going to compress it horizontally. So if I have a function and it's 5 times x, that's a compression of, what's the reciprocal there? 1/5. So you want to think reciprocals when you're doing scale changes with the x. Okay? If I have a function, that's a horizontal stretch, yes, by a factor of 2, reciprocal. Keep in mind, if you have something like this, that's the same thing as multiplying by 1 over 7. All right. Okay. This is the slide. If you want to write a slide down, this would be the one I would write down. Okay, it has everything to it. So take a moment. Remember, if it's happening outside, those are vertical changes. If it's happening inside, these are horizontal changes. Okay. The f of just means whatever function we want to put in there. Let's see if we can answer these. So, looking at this, it's a square root function with some transformations. There's 3 things happening. First thing I'm going to say is that. What does that do? Okay, reflects over the x-axis. Remember, it's outside, so that's a vertical flip over the x-axis. The other thing that is outside is this guy. Down 3. Inside, we have plus 4. Which way? Left 4. So opposite, right? You would think plus means you're going to move to the right. No, 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 you're going to move to the left. Do just one thing at a time. Now, if you have a number multiplied to your x that is not a 1, you need to factor that out. Okay? So this guy here technically has a number in front of the x. What is that number? -1. So I'm going to factor it out. And then I'm going to start pulling. What does the 1/4 do? So it's outside, right? So it's exactly what it says. It's vertical compression by 1/4. The other outside guy is +2, so it's going to go up 2. Those are my vertical things. Everything else we're going to talk about is opposite of what it would think. So the -1 is a reflection over the y-axis. I'm running out of colors here. And the -1, we're going to move to the right one. Okay? Are we good with those? Do we have to continue? We're good? We're golden? Skipping the last one. Okay, let's write the equations. X is shifted 2 units down. So where would that 2 be? Inside with the x or outside? Outside. Plus or minus? -2, because down means minus. Reflected over the x-axis. So is that an inside negative or an outside negative? Outside. Compressed vertically by 1/2. Inside or outside? Outside by 1/2. There's nothing going on horizontally there. All vertical. Okay. We've got the graph of 1/3, x cubed. So we're going to do this. Always make a little bubble. Just cube outside. 4 units to the left. So it's going to be x plus 4. Stretched vertically by a factor of 3. 3 on the outside. Reflected over the y-axis. Negative inside. And shifting 2 units up. Plus 2. You get the drift. We have to do the third one. Last slide. Oh, it's 2 o'clock. We can do it. We're going to do the first example. So in words, what's happening here? Good. Vertical compression by 1/2. And we're going up by 1. Everyone agree with that? If I were to write that with translation language or transformation language, this means there's nothing happening horizontally, so the x is going to remain the same. And the y values, if you look in the direction, they tell you to do horizontal shifts first, stretch and compressions next, reflections, and then vertical shifts. So I'm going to do the compression first to my y's, and then I'm going to add 1. See how you can write the rule that way? It tells you exactly what's going to happen to the x's and the y's. So I have a set of x's and y's here. My x -5 is not going to change. My y -3 is going to multiply by 1/2 and add 1 to it. My next point, -1 for the x does not change. -1 for the y is going to multiply by 1/2, and I'm going to add 1 to it. And you just kind of go through and make your new table of values. Only the y's are changing. Nothing else is going on here. Okay, and then you just graph your new points. So you have -5, -1/2. -1, +1/2. 1, 2.5. 4, 0. Make sense? So if I were to go back, maybe, and write this, for instance, this first one, as a transformation rule. What's going on with the x's? How do I write x left 4? In reality, what are you doing to every x? You're subtracting 4 because you're moving it to the left. So what actually is happening is opposite of what's happening in the equation. The equation is lying to you. For the y's, there's 2 things that's happening. You're multiplying by a -1, and we are subtracting 3. Okay? So the x's, your words are saying what you're actually going to do. So if I'm moving left, that's subtracting. Okay, that's what actually happens to the graph and to the points. All right, we good? These are so cool.